All right, I want to show you 523 and 524, which I'm very happy with. It took me the last couple of weeks to write these. I was motivated by the Taproot upgrade in the Bitcoin protocol. I've become convinced that Bitcoin is inevitable and it's not going to fall to zero anymore. I actually bought some Bitcoin. I'm now a hodler. So someone needs help with something in Project 501. Yeah, we'll get to that after the demo. All right, anyway, so 523 was 523, right? Well, it's going to be ZK SNARKs. These I'm very pleased with. I've always heard about ZK SNARKs, and I finally figured them out and wrote them up here. ZK SNARKs are zero-knowledge proofs, and this is really important. If you consider the current system we use for encryption and authentication is pretty horrible. For example, consider logging in to Facebook. You want to log into Facebook, you type in your username and password, you send your password up to the Facebook server, which then compares it to some stored value to decide whether it's correct. Now, why should Facebook know your password? Why did you release your secret to them? All they really needed to know was that you know the correct password. Sending the password to them is something you didn't need to do, and this, in fact, is what Mark Zuckerberg used to steal the passwords of journalists in 2010. Mark Zuckerberg did not like what journalists were writing about Facebook, so he told them to change the programming on the Facebook page to automatically refuse the first 2 times people tried to log in. So everybody used shared secret passwords at that time. You used repeated passwords, same password on many sites. So he would record all the password attempts, and he would get their password that way, and that would also be the password to their email, because everybody will try to log in, and when it fails, they'll try their other password, and maybe their other password. So he configured his server to steal the passwords and used it to go into the journalists' emails and steal their emails to find out what they were writing about him, which is fantastically illegal, but nothing happened to him. Just like most rich people in America, we're a corrupt society, and when rich people do something, nobody bothers to prosecute them. That's why you observe Donald Trump and many of these gang, they're not going to go to jail. They can't go to jail because we're a corrupt culture, and nobody can prosecute Mark. But the point is, it does show a flaw in the American legal system, but it also shows, as we've seen, our courts and government are not much good at dealing with corruption, but technology might be. You could log in without sending your password to someone. And there's another case. Kaiser, for example, might have your complete medical history, and somebody might want to know whether you've been vaccinated for COVID. You would like to answer just that question instead of somebody having the password to see your whole history. Yeah, that's right. Yeah, it's good that they had that victory today for Ahmaud Arbery. All right. So anyway, this is the point of a zero-knowledge proof. ZK SNARK stands for this ridiculous thing, non-interactive argumentative knowledge. The point is, you can create a cryptographic object which can be used to prove one fact without releasing all the stored data. And this was a big deal. It started in 1987, a new approach to protecting secrets, and on it goes. And Matthew Green, by the way, is on Twitter. He's a very famous cryptography at Carnegie Mellon. He's really not messing around. And he's on the Zcash board. Zcash is the cryptocurrency using zero-knowledge proofs. So he's very advanced, very technical, very nice, and I'd like to add it to my class someday, but first I'm doing the big ones like Bitcoin and Ethereum and Cardano. So you can make ZK SNARKs. You have to get a Linux machine, install Node, install Rust, install Circom, which is what's going to be the circuit compiler, and then you can install SNARK, which is JavaScript that's used to make these SNARKs. And now it's complicated. You configure something called powers of tau that pre-calculates a whole bunch of junk. And then you build a circuit. And the circuit has a private input, a public input, and then it proves that you can calculate A times B and output of C. So it doesn't prove anything very meaningful here. It just shows that you can create a ZK SNARK that shows that you have the ability to do this calculation. So here's the description of the circuit, and you can compile it, and then you end up, since you created 1,000 of those powers of tau, which are like 1 bits to calculate arbitrary numbers, you now have 1,000 nonlinear constraints, and so on, 1,003 wires connecting things, 1,004 labels. This is the circuit diagram of the object you have created here. And now you can, here's the constraints of the circuit, of which there are about 1,000 going up to 998. And now you calculate a witness, which is sort of like a challenge value used to prove it. So I'm only going in general terms, but the point is you can create these witnesses, and then this thing will create a smart contract, something called a Planck proving system. And you create the proof and export the proof to a smart contract, which is in Solidity. So then you copy that Solidity contract and put it in Remix. And you can now run that proof on the blockchain. And at the end, after it's all over, you can ask this question: Does the person have the ability to multiply these two numbers? This challenge will answer that question without giving you any information other than that. And the end result is it verifies it's true. You feed in that whole thing like a whole page of binary, of hex, and you verify the proof, and all you get is true. And this is the point. That could be your whole medical history. And wherever you're trying to get into a nightclub, and they send a cryptographic request, and all they get is true. This person is vaccinated. They don't get access to all your data. They just get one question answered. That's a zero-knowledge proof. And it's closely related to homomorphic encryption. And as you can see, there's a lot of reasons to do this these days. So even though it's pretty much a mess, it'd be good to get a little practice setting it up. All right, let me stop this one.